This is the homework from last Friday. Let's zoom in a little bit. Okay, so we're going to find final speed and direction of the masses after they collide. It's inelastic, so that means they stick together. So they become a big 8-kilogram blob moving upward and rightward at some velocity v, and the direction is the angle from the horizontal. That's where we almost always measure our angle, okay? The components, you can do this a couple different ways. The vertical and horizontal components for velocity are going to be v times the cosine of theta and v times the sine of theta. So we can write like a horizontal and vertical equation, similar to what we do with the more complicated problems. Don't have to do it this way, but I'm going to show you, and then I'll show you kind of an easier, quicker way to do it. So horizontal momentum is 5 times 6 before the collision, or 30 kilogram meter per second. That's it. There's no horizontal momentum there. I could do plus 0, but you're going to just trust me. The horizontal momentum after collision is 8 times v cosine theta. So 8 times v cosine theta. Vertically, 3 times 4 is the momentum. So 12 kilogram meter per second. And that'll equal 8 times v sine theta. So now I have two equations with two unknowns. And can anybody see a trig identity that would be handy to use at this point? Yeah, the tangent, which is sine divided by cosine. So if I should have done vertical on top, but if I just divide the two equations, right? One divided by the other. The 8 cancels, the v cancels, and sine over cosine, so if I write it like this, sine over cosine, which is tangent, is equal to 12 over 30. So I can solve for theta, right? First, get about 22 degrees, 21.8 degrees. Keeping an extra sig fig around for now. And then come back here to either one of these original equations, put in 21.8 and solve for v, either here or here. So 30 divided by h divided by the cosine of 21.8 degrees equals 4. So v equals about 4.1 meters per second, or 4.0 depending on when you round. Another way to do this would be to just transfer the numbers for the horizontal and vertical momentum to this side of the equation. So now ignore the pink. 6 times 5 is 30, so the horizontal momentum is 30, so I'm going to put P equals 30 kilogram meter per second. And the vertical momentum is 12 kilogram meter per second. Okay? So then we can just do Pythagorean theorem. 30 squared plus 12 squared equals the hypotenuse squared. I'm going to put P squared. It's momentum that we're solving for. It's not velocity. Okay? The resultant, or the hypotenuse, is about 32. So 32.3, keep an extra sig fig around, kilogram meter per second. I know it's hard to read that. So velocity will be momentum divided by mass, or 32 divided by 8. Hey, the velocity is about 4. Okay? And then you could use any, tangent would be a good one. Tangent is, oh look, 12 over 30. So you're really doing the same thing, it's just a little bit quicker. Okay. Number 2, find the final speed and direction a bullet embeds itself in a block. Be careful of units on this one. So we have, after the collision, a block which has a mass of 3.03 kilograms. Because the mass here is 0.03 kilograms. Okay? And that will head off in this direction. Okay? So again, I'm going to use that horizontal vertical momentum stuff. 0.03 times 300 gives us a momentum of 9 horizontally. 9 kilogram meter per second. And vertical is going to be 3 times 5, which is 15. Of course, the bullet has a large-ish momentum because of its large velocity, and of course this has a large-ish momentum because it has a much bigger mass. So the resultant momentum is going to be the square root of 9 squared plus 15 squared using Pythagorean theorem. And we get a resultant momentum of about 17.5. So the velocity is going to be 17.5 divided by 3.03, dividing out the mass, and I get about 5.8. And then the direction, remember that when you solve for an angle, you have to use similar terms. So I don't want to mix 5.8 with the 9 and the 15. Those are momenta, right? The plural of momentum. And this is a velocity. So just don't use the 5.8 when dealing with this triangle. If these were in velocity terms, then you'd be fine. Okay? So I'm going to use tangent, 15 over 9, and I get about 59 degrees. Okay. So I'm going to leave number 3 for you guys to figure out. The answers are online. The tricky part here is you have the horizontal but not the vertical because that's unknown. So carry that horizontal over, sort of finish out your triangle, and then you can work backwards and get the vertical. Okay? Now let's do the harder ones on the back. No, that's where. Okay. These are elastic, so they don't stick together. And the same method, the same approach holds true. So horizontally, the momentum is 6 times 2, or 12 kilogram meter per second. This is sitting still, so that's 0. And it's going to equal a sum of the horizontal momenta after collision. So I'm going to finish out the triangles here. And I'm going to write these components out in terms of their velocity. Well, and you'll see in the equation, I'll make sure to include the mass. Since that's momentum, this side also has to be momentum. So the horizontal velocity is v cosine theta. The vertical, v sine theta. Horizontal velocity here, 3 times the cosine of 36. And the vertical, 3 times the sine of 36. So horizontal momentum will be 2 times that velocity plus 3 times this horizontal velocity. Okay? Plus because they're both heading in the same direction. That will not be true when we get to the vertical. So everything is rightward, so everything gets to be positive. Remember, momentum is a vector. So 2 times v cosine theta plus 3 times 3 cosine 36. Vertically, How much momentum before the collision? 0, right. No vertical momentum before collision. After collision, you have up and down. So you pick which one do you want to be positive. Sure. This one's positive, this one's negative. Okay? So the momentum is 2 times v sine theta minus 3 times 3 sine 36. Okay, so I'm not going to actually solve this, but now you're going to have this equation, and you're going to solve for this expression right here, since both of those unknowns are linked, right? Multiplied. And then you're going to do the same thing here. And again, what trig identity should you use when you don't know the sine and the cosine function? Tangent, yep, sine divided by cosine. Let me give you just those numbers. So v sine theta, I'm just going to solve for that number, will be 3 times 3 sine 36 divided by 2, 2.65. And the cosine theta, if I solve the horizontal equation, is going to be 12 minus, and then divide by 2. 3.29. Then you're going to use that trig identity. The v's will cancel, which gets us down to one variable, and then go back and solve. Okay. And the last one, we have a can that's thrown upward and a rock that's thrown horizontally. It's an elastic collision, so similar to the one above. I'm going to write out the horizontal and vertical components just for velocity. So 6.8 times the cosine of 65 degrees and 6.8 times the sine of 65 degrees. Horizontally, v cosine theta. Vertically, v sine theta. Horizontally, the mass before collision, 0.55, times the velocity, plus 0 horizontal momentum right here, equals the mass times the horizontal velocity, 6.8 cosine 65, plus, everything's positive because it's all moving to the right, 1.4 times v cosine theta. Vertically, 0 plus 1.4 times 5.7 equals, and again we're going to do a positive here and a negative here. Positive here, never mind, 0.55 times 6.8 sine 65 minus plus, I'm stuck on that this morning, 1.4 v sine theta. So you're going to solve it the same way. Isolate v sine theta, isolate v cosine theta, and use your tangent function. I am putting this work up on the website for kids who aren't here, so you can double check this if